Yes, so we are asking the question, should we secure by design or not? So let me go to the next slide. So about me. So I'm Jakub. I'm based in Poland. So I have 17 years experience in IT. Currently, I'm focusing on the cybersecurity on the IT and OT field because I would say it's extremely important for the companies, and also it's some kind of hobby. I have experience as the engineer in various companies around the globe. Um, I'm working closely with the NIST standard ISO, which are working in the cybersecurity. And privately, I'm ambassador of the Artifred project and also a collector of the vintage computers, as you can see on my back. So let's start with the introduction to the embedded security. So what are the embedded systems? Because when we go to the factory or some location, we can see many of the devices. So most of them are just PLCs, HMIs, sensors, some Linux machines, some computers, which using special versions of the operating systems, and we are using them widely in the industrial control system or OT environments, different name, IoT environments, building management systems, automotive, medical, and many more. So we can find them at home, we can find them in shops, in the plane, in the car, in the power plant. So they are everywhere. So even I would say microcontrollers you can find in the dishwasher and can be hacked. So let me go to the another slide. So what's the secure by design concept? Well, this is some kind of, I would say, approach which from beginning set some specific goals and requirements to the project. Could be the software or hardware or both, which follow specific standards. And then once you have a special requirements from the business, you can develop the proper maturity of the cybersecurity on this product. So with this approach, you can analyze specific risks, you can minimize it since beginning, and then avoid future maintenance. So I would say maybe less maintenance, less patching, and less cost for the business. So let me talk about the CIA triad. So it's not the CIA from US. So it for the IT world, we have confidentiality, which is encryption, access control to protect the data. We have integrity, so checksums, hashing, digital signatures. So once, for example, you have a document, and when you're sending to someone, you want that the document is the same and the data is the same, it is not changed by malicious actor. And the next thing is availability, which is redundancy, fail-safe mechanisms. So you want that your system will be available all the time. But this is for the IT, right? But what about the OT? So in OT is quite different. So OT guys thinking that availability is on top, right? Because the downtime in the factory costs more than, for example, losing the specific data in the confidentiality in the IT. So people which are designing the systems, the hardware, the equipment, they are looking for the situation where the machine, the robot, or whatever will work all the time without any stop. So that's the most important. And then we have some kind of conflict between the IT and OT worlds, because IT guys wants to patch everything, OT guys won't, because they don't have maintenance window for that kind of purpose. And that's why we need to somehow split it. And that's why secure by design helps a bit, because by this proper concept and proper maintenance and patching from the beginning of the design and the development of the product, we can solve this problems with the confidentiality and integrity, and still save the availability, which is on the top. So I was thinking how we can perform, and how we can design, have a like a security by design embedded systems from the beginning. So there is some kind of, I would say, very high level approach, which start with the design phase, right? So once you have some kind of system, like I mentioned before, could be the software or hardware. First of all, you need to think about the potential threats you may face in the different phases. Also, you need to find out the specific requirements. Could be requirements from the customer, from the business, from yourself, if you're selling specific production, or can be like from the government, if you're working from the government. Another next step will be development and testing. That's the, I would say, also important part, because once you have I would say, fundamentals, during the development, you have to scan the software, and once you found some vulnerabilities, some bugs, it's much easier to patch it on the development and testing phase instead of production. Also, in this phase, you can educate your developers or contributors to follow the best practices, and then they can minimize, for example, legacy support and any other. So the next phase is deployment and maintenance. So you need to make sure that you're following like a secure boot, which you can run only trusted code. You can find it, for example, in mobile phones, where you can run only specific software from the vendor, and you cannot install anything else unless you unlock the bootloader. So it's quite a good option and solve a lot of issues. Another thing will be patch management, and part will be vulnerability management. So you have to make sure that you are updating regularly firmware and also addresses vulnerabilities. The good thing also could be the bug bounty program, where some other people can find some bugs, and then you pay some kind of price for these people, and then you can keep the risk and security level, risk level on the low, but security on the high level. And the last one will be decommissioning, which you need to allow to securely wipe sensitive data, because sometimes there is a problem when we have some embedded device and it reaching end of life, and to be fair, we don't know what to do from the operational point of view. But if you give some option to wipe it completely, that solves the problem with the potential data breach. So the next slide will be about the secure design principles. So when I'm working on some kind of project, I'm not the developer, but when I'm implementing some solutions, I'm trying to base on the specific standards. People ask why. So the answer is very simple. I would like to avoid inventing wheel again, because someone did it. And I would say the most important standards in OT world or embedded systems is ISC 62443, NIST, and ISO 27K. So based on the standards, you can organize all the parts I mentioned before in the life cycle. So the development, the design, development, maintenance, and the commissioning. So based on that, you can reduce the risk, and you can develop secure solution much quicker than without any standard. And also, these standards give you some kind of guideline what you have to do step by step, that you have to create the policies, documentation, etc. So it's much easier later on to go to the, I would say, high quality product. So I would like to guide you to follow the I would say main principles. So first will be eliminate default passwords. So in many devices you have like an admin, and people in many situations are not changing this password, and scanning using the Shodan or any other, you can find devices exposed to the internet that you can just connect and hack, which shows in the short video earlier this presentation what could happen. The next will be conduct a field test. So once you have a device or software or whatever, just test it as much as you could. You can make pen tests. You can scan using different tools. So you can prevent many issues later on. So the next will be streamline hardening guides. So once you simplify measuring the security within this device, you can easily address specific risks. Also, you can provide some implementation of the controls and aligning with the specific standards. Another will be discourage unsafe legacy features. So that's also important. So if you really don't need to support SMB v1, don't do that. Just do not enable. If you enable as less as you can, that's the safest way. Even if it's modern solution, because then you can minimize the potential options where hacker can use it to get access to the device. Another I would say principle would be implementation of the grabbing alerts. So you can implement SMTP or any other function to SMP to inform people about the non-standard behavior of this device. So also, if you have a functionality to collect with SIEM solution, that gives good benefit for people like me. So I can collect the information from the PLC or HMI or whatever about the non-standard activity of the device, and then I can act. If not, then we need to use the specific equipment to learn about the behavior, and this takes time and this costs a lot of money. Also, the last one will be creating secure configuration templates. So if you releasing something like a software, it's good to support the people with the good practices, how to secure. So you can release like a standard system, standard software with the I would say without multi-factor authentication. However, when you share the blueprint, then people can follow it to make it secure on the specific level. And there's a good sentence where the software industry needs more secure product, not more security product. Software manufacturers should lead that transformation. So on the market, we have a lot of software and systems like Nozomi, Takes One, and many more about the security in the OT. However, would be much easier if we have a secure equipment already, and we don't need to spend time to and money for that kind of software. So I would like to talk about threat landscape a bit. It based on the IT and OT environments, based on the ENISA 2023 report in Europe. So as you can see, the prime threats are ransomware, and when they hit, you need to pay a lot of money or you have a problem. The next is DDoS. Then we have standards of data, malware, social engineering, information manipulation, web threats, supply chain attacks, zero-day. But the ransomware is the biggest thing. And once we jump to the sectors, we can see we have a lot of in public domains. However, we have 7% of manufacturing, which is not the total list of the incidents, but only reported to ENISA. But we can also finding the 4% in energy. So this is the big thing. Last year was an incident in Denmark where energy sector was hit by ransomware. So there was a big thing, and everyone was talking about this, how to prevent it and what they could do better. So next slide will be about the case studies and examples of the threats. So mentioned on the chat, so Stuxnet malware was discovered in 2010, but was developed before as many malwares. The target was SCADA systems, mostly they based on the Windows, and the problem was with the zero-day exploit, the Microsoft Windows operating system. As you know, there is a delay in the patching the OT-related systems like a Microsoft. Currently, there is a better situation, so we are patching. But I know that previously was a big problem in many companies. However, it hits to the Siemens step 7 for the SIMATIC PLCs, and then they were able to infect 200K computers and more than 1,000 machines to physically degrade. So it's a big thing, and they could do a lot of issues, like they affected the Iran and PLCs. Another is, I would say, fresh case was a Florida City water supply. So Max, you may heard about it. So the attacker was able to get into the systems using the TeamViewer and get the control over the systems. However, luckily, the operator found that there's something wrong on the HMI. That's why he was able to act very quickly, and then the security team was able to just cut the connection, and then they were able to mitigate the problem very quickly. However, this shows that OT is a big thing, right? Because can harm not only the business, but also can harm normal people to make water toxic. The last one of the example will be Mirai botnet. So it was a bunch of devices like home routers, air quality monitors, personal cameras, and many other IoT devices you have at home were affected by this botnet, which sends and then infect itself, and was because the security in this device were very bad and they were connected to the internet. That's why the attackers were able to quickly spread across the globe. So you can see that 600K devices were affected. So it's a big thing, and a lot of services were down because of that. And this device, once connected to the big botnet network, were able to make a DDoS attack for some specific services. So you could use it to attack some companies or some other, I would say, services or whatever. I will talk a little bit about the RT-Threat security. So as you know, it's a real-time operating system and compatible with POSIX. So it has security features built in, which are very useful. Because of using the specific CPU architecture, and you have a lot of support board packages, you can easily during the development of the package or on your system, you can choose what do you want to do, implement. So you based on the specific, I would say, requirements and also the plan and the secure by design, you can run the encryption, anti-tampering, breaking point resume, intelligent restoration, and backtracking, right? So also, as I mentioned before, it's worth to disable what you don't need, then not enable everything, because once you develop some kind of solution based on the RT threat, would be easier to attack if everything is open, right? So if you compare to the house, if you have open all the windows, so thief can just go inside without making any noise, right? So now I would like to talk about future trends and challenges in OT security, and also secure by design, because it's I would say it's extremely connected. So the first is mentioned before on the chat, AI and machine learning, and I can see it's a big thing as it helps people to write the better code. However, can also make some kind of mistakes, depends of the learning model. Also can expand the attack surface, right? So we can have a different attack surface that we are not aware and we are not prepared. People can use the AI to write specific viruses, and then they can create another viruses, and then another, and then all this malicious software can attack your system independently. So that's the big problem. So the high cost also, it's a big problem, because from the as a person who is working in OT security, I have to spend a lot of time and resources to find out how AI can harm our systems. So, and always I'm quite behind because AI is much faster, right? So with the AI also we can find more incidents raised by script kiddies. So the kids who they have a lot of time and they are just they have a fun to breaking something. They can use the code AI can create for them, and then based on that we will have a more. And I can see that we have a lot of traffic, and we have a lot of situations where some kind of software trying to attack us. Luckily, we have a good security controls based on the standards. The quantum computing will be the second. So I would say the biggest risk is in the IT security. However, OT might be affected as well, because not more than 90% attacks came from IT to OT and to the embedded systems, right? So once the quantum computing will be more, I would say, often used by malicious actors, we can have a problem with the encryption, because quantum computers can break encrypted algorithms, right? So we need to be prepared for the new challenges regarding to the designing the embedded systems, and also the protecting embedded systems, the patching, and many more. So it's a big thing, right? So we are going to summary. I would say there's no one fix. There's no solution for the secure by design. It's always you have to be very flexible when you're doing preparation to make product secure. However, you can avoid some few basic mistakes. You can follow the specific standards, and once you can minimize the risk and make your product safer and also easier to protect by me and my colleagues in cybersecurity area. Thank you.
Well, thank you, Jakub. Again, I hate security. So Paul asked, is unit testing not enough to somehow implement embedded system security?
Well,
I suppose it depends what you mean by unit testing.
I would say if you have a so what I'm actually doing before we are deploying some solution. So we have a lab. So once you have a lab, you can see some kind of behavior, how it works, and on the one hand, you have to do like a blue team activities. So you have to look for the behavior, and on the other hand, you need to be a attacker. So red team activities. So you can see on the two sides how it looks like and what kind of data you can extract and how you can analyze it, and then you can avoid specific threats. So if you have a communication between, I would say, the PLC and HMI, you can first of all analyze the traffic, what kind of protocols it is using, and only allow this kind of traffic. And any other like SSH or SMB, you need to block from the network perspective. And you can do it on lab, and then you can add to the production.
Do you actually offer a service where people can say, I've developed this, can you test it for me?
Well, I would say it's that as far as I know, there are some services. Also, if someone reaching me out on LinkedIn, I'm trying to help to make some solutions secure. But it's I would say it's a big thing. But following the standards and the principles, it can show you what you have to do to make it secure. Because normally, like if you ask some companies who doing some like PwC or whatever, McKinsey, to look for your solution, might be extremely expensive.
I like the idea of the unit not having a default password like admin or password.
Yes,
forcing you to give, you have to put a password in and making, make them choose a real password.
Yeah, I would say the good example might be Supermicro. When you're buying the new mainboard, you have a password. So the password is on the sticker on the specific mainboard, and it's aligned. It's like I would say random. It's not based on the MAC address or whatever. And they changed from admin to just custom password, and I would say it's a good choice.
All right.
Or some vendors forcing you to change the password on the first boot of the device.
That would be good too. Can I ask you to post your email in the chat so that people can contact you if they need to?
Yeah, always.
And I was interested in your love of retro computers. I mean, yeah, I had so many in the past that when you didn't think that they would become collector's items, and I gave them away to friends and things. But I don't know if you ever saw. Did you see the thing called the C64?
Yeah.
It's a replica of the Commodore 64. It's actually based on an FPGA. But it looks and feels just like a Commodore 64, except that it's got an HDMI output, so you can plug it into your modern TV. I've got one of those. You can program it in BASIC, and it comes loaded with 64 classic games. That's pretty exciting. I love that.
Yeah, I would say these computers are only part of my collection. So on the, I would say, second room, I have desktops, which are quite bigger, like a Sun Spark.
Oh,
yeah, and the water cooling PowerMax G5.
I remember using Suns back in the day.
Yeah, amazing machines.
Oh, they were, for the time, they were incredible. Okay, thank you so much.
Thank
That
you.
was an absolute pleasure listening to it. And you're going to be very happy with what I'm about to say now, because here are the names of our next 5 winners. And good Lord, look who's there.